In this session, we will be starting new concept which is bit manipulation. So I'm sure that many of you will be heard this concept, but only few know how to solve this thing. The main purpose of this is you can solve in less time complexity and less time complexity and less LOC, which is line of code. Okay, so one more thing you can impress your interviewer if they ask any simple questions, right? You can use bit manipulation and solve that question so that it proves that you know concepts related to DSA. So before going into bit manipulation, you want to consider how to write. You want to know that how to write numbers in binary. So here is a list. Let me just take a screenshot of it. I'll just take screenshot of 20 and I'll just open it. Okay. So for basic knowledge, you should know how to write each and every integer in binary. So guys, can you say what is the binary number for 5? How we will write binary number for 5?
101.
Yes. So 101 is a binary number for 5. So when we come to the topic of bit manipulation, we will be manipulating our given integer by bits. So we'll not take an integer in this format. This is called as decimal format. We will not consider this in the decimal format. We will convert it into binary. Anyhow, our compiler will convert each and everything into binary, right? So we will manipulate using binary itself. So how do we do that? By using some operators. So there are many operators in bit manipulation. Here I will be listing few. So OR operator, how we will use is 5, for example, 5 or 3. So what do you mean by 5 or 3? Here, as I mentioned earlier, we will be converting this into binary. So 1, 0, 1. Or what is the binary of 3? 0, 1, 1. So what is the OR operator? OR operator you guys already know. If 0, 0, 0, 1, 1, 0, 1, 1. For OR operator, what will happen? The 0 zeros will be 0, 0, 1 will be 1, 1, 1 will be 1, 1, 1 will be also 1. And for AND operator, what will be there? If only both are 1, then it's 1, otherwise it will be 0. So that is the basic principle. Like you have learned this in logical gates, right? So same thing will be applied here. 1 or 1 or 0 is 1, 0 or 1 is 1, 1 or 1 is also 1. So what is the logical or what is the OR of 5 or 5 and 3? That is 7. Let's come to AND. These are just the basic operators. I am showing you guys how this operator works. That's it. If we take 5 and 3 at that time, I'll just here itself 1 and 0. So 1 and 0 is 0. 0 and 1 is also 0. 1 and 1 is 1. So the decimal conversion will be 1. So 5 and 3, the decimal conversion is 1. Next one we will majorly used is XOR. So what do you mean by XOR? We will represent it like this. 1, 0, 1 XOR 0, 1, 1. It will return 1 only if these two are different. Like here we are having 1, here we are having 0. These two are different, right? At that time we will return 1. Here also 0 and 1, these two are different. That time we will return 1. Here we can see these two are same. Either it may be 0, 0 or either it may be 1, 1. In that cases, it will return 0. So this is 3. 1, 1, 0. The the decimal conversion of this 1, 1, 0 is 3. Oh no, 1, 1, 0 is not 3. 0, 1, 1 is 3. What is 1, 1? 6. Yes, 1, 1, 0 is 6. Next one, this is also very simple, that is not. So not, for writing not, we can have only one integer itself. So not we will assign by this operator, and what it will do, not of 101 will be, it will toggle all the bits. So 1 will become 0, 0 will become 1, 1 will become 0. What is this? This is 2. Next one is left shift. So left shift and right shift, this is the thing which we will use. Not, I think we don't use frequently, right? We will use it frequently. In some cases, we will use it frequently. So basically in bit manipulation, right, we will not directly use the operators. We will use the functions. We will use the helping functions. Helper functions. We have seen this, right? We have seen this in previously when we were using arrays and strings, when we will be solving arrays and strings, recursion, in all the concepts. So we will be using builder functions or helper functions. We will just assign work to them and we will consider that that work is already being executed. So in bit manipulation also, we will write few things, and in this today's class especially, we will be learning to write those building functions and how does those work, so that in real world, in interviews, if they ask any big question related to bit manipulation, you can use this builder functions. You don't have to start it from scratch. DSA is all about pattern, right? We have just in yesterday's class also we have seen pattern related to graphs. In previous classes, trees. Like that, we will create a template for this also. Here, the main logic is knowing how each and every builder functions or helper functions work. That's it. Left shift. What is left shift? If we get like 5, left shift of 1. At that time, what is 5? 1, 0, 1. All the bits will be shifted one left side. How many times? One time. So this will shift here, 1, this will shift here, 0, this will shift here, 1, and in this place we will write one more 0. So what is 1, 0, 1, 0? So guys, this is easy. What is 1, 0, 1, 0? This one is standard, right? Come on, guess.
I mean, multiply by 2, right?
Yeah, but I am asking the decimal conversion of 1010. What is the decimal conversion of this 1010?
10.
Yes, exactly 10. So by this, what we got, if we are getting 5, we are getting 10. So basically, what this left shift do is, if we left shift by 1, it will multiply the given element by 2. This was the thing which I wanted to derive, but you already said it. It's okay. So when it comes to right shift, if we write 5, right shift 1. So in 101, what will it become? This 1 will come here, this 0 will come here. Wait. So we have right shifting, right? This one will go, 0 will be shift. Let me just show you in this format, then you will understand it. Okay, 1, 0, 1. You have to right shift. So we can't just create one more space here and dump it. So we have to eliminate this. We will shift this 0. We will shift this 1, and here we will just write 0. So what is 0, 1, 0? It is 2. So if we divide 5 by 2, we'll get 2.5, but the integer conversion is 2, right? So basically divide by 2. Right shift by 1 is considered as divided by 2. Left shift by 1 is considered as multiply by 2. This is like a shortcut. I think you guys understood it. If you are having any doubt, you guys can ask at any time. These are few operators which we'll be oftenly using in our bit manipulation. OR operator, it will return 1 if any of the value is 1. If both are 0, then only it will return 0. In AND, if both are 1, then only it will return 1, otherwise it will return 0. In XOR, if both the values are different, then it will return 1. If both the values are same, no matter 1 1 or 0 0, it will return 0. Not, it will just toggle. Left shift is basically multiply by 2, right shift is basically divide by 2. This is the prerequisites